Okay. November 2020, paper 6, variant 3. Question 1. Some students investigate the transfer of thermal energy from a beaker of hot water, and they have some apparatuses, beaker A and beaker B. Okay, it's quite obvious. Beaker A is without a lid, beaker B is with a lid. And we have a thermometer. This is the room temperature. What is the room temperature? What?
24.
24 degrees Celsius. Okay, yeah. 24 degrees Celsius. A student pours 100 centimeters cubed of hot water into beaker A. He records the temperature. Okay. The student records the temperature theta every 30 seconds. His readings are shown. Can I fill out the table, complete the headings and the time column? Can I complete the headings and the time column? الهيدنجز
إيه.
T theta ها.
هنكتب
second.
30
You go with
هنكتب
30 ماشي 30
30 60 90
مم.
120 160 180 وبعد كده 210 200
خلاص that's
plus.
it that's it ايه 30 60 90 120 150 180 what about T
Second.
theta seconds okay theta what's theta
I think degrees Celsius.
degrees Celsius and theta is also degrees Celsius حلو describe a precaution يلا that should be taken to ensure that the temperature of the readings are as accurate as possible. What's one precaution?
Take the reading perpendicularly.
Yes, take the readings perpendicularly. Take the readings perpendicularly. Write a conclusion stating how the use or how using the lid affects the cooling of the water. With the lid and without the lid. How does it
Avoid
affect?
avoid the steam from going out.
Avoid the steam from going out.
Decreases the cooling rate of the water.
Okay. Again, I want to talk about the cooling rate of the water. I have to say that it decreases the cooling rate of the water. How did I know? Okay. How did I know? From the table above. Without the lid, initially it was 85 and finally it was 56. So without the lid, okay, without the lid, the water lost how many degrees from 85 to 56? Can someone calculate it? 85 minus 56.5. 28.5, I guess. Huh?
Yes,
28.5
and it's 28.5.
degrees Celsius in 180 seconds. With the lid, it only lost from 86 to 76, which is 10 degrees. 86 minus 76, it only lost 10 degrees Celsius in 180 seconds, which means that the cooling rate, decreases. Cooling rate decreases. What do I mean by saying that the cooling rate decreases? It means that it loses less energy, it loses less temperature and the same amount of time. If I say that the cooling rate increases, then it will lose more energy. Okay, the temperature will be even less. Okay. The temperature of the water in each beaker decreases during this investigation. Describe one other similarity in the pattern of cooling the water in beakers A and B. We need to see one other similarity in the cooling of the water in beakers A and B.
Both have a larger of the experiment.
Both have what?
Both have a larger cooling rate at the beginning of the experiment.
Okay, so we can say in other words that
Mister, can I say another thing? They had a similar initial temperature.
لا this is correct. It is correct. But that's not what he wants you to say. He does want you to state that the cooling rate of both, okay, of both beakers A and B decreases with time. The cooling rate decreases with time. What do I mean that by the saying that the cooling rate decreases with time? For example,
Mr. He already said that in
لا
the question line.
لا wait بس let's calculate مثلا in the first 90 seconds. Okay, in the first 90 seconds, B lost how? It was from 86 to 78, which is 7.5. Okay, in the second 90 seconds, it only lost 2.5. طيب, what about A? A in the first 90 seconds, 85 to 68.5, which is 17, 17.5, I guess. Okay, someone help me out. Or maybe 16.5. Okay, plus 16.5, صح? Am I correct? But in the second 90, okay, in the second 90 seconds, it only lost how much? It only lost 12. يبقى definitely, the initial cooling rate is always greater than the final cooling rate. Meaning what? Meaning that the cooling rate always decreases. Okay. One similarity is what? That the cooling rate decreases with time. Or that the cooling rate decreases as the temperature falls. Okay? Yes.
يعني مستر حضرتك قلت حاجة زي إن الإكزامينر هيبقى يساعدنا، يعني إيه هيبقى يساعدنا شوية؟
لا
يعني
هي مم.
يعني من كام سيشن حضرتك قلت الإكزامينر هيبقى يساعدنا.
لا I mean ان هو he will give you the table and the numbers are clear in the table. The numbers هنا are clear that cooling rate initially in A was high and then the cooling rate decreases a little. Also in B you have the same thing. Okay?
آه.
طيب. Calculate the average rate of cooling XA in beaker A, where T is 180 seconds. I need to find theta 0, theta 180 over T, which is very simple. Yeah. In beaker A, 85 minus 56.5 divided by 180. Yeah. 85 minus 56.5 divided by 180. Theta 0 is the initial temperature. Theta 180 is the final temperature divided by T. He said that T is 180. Can someone calculate it and include the unit? Can someone please calculate it? Any help?
0.158
0.158. What is the unit?
degrees per second.
Degrees Celsius per second. Yeah. The next one, beaker B, started at 86, ended at 76. Yeah, this is easy. Yeah. 86 minus 76 divided by 180, which will be hmm, yeah, what is it? شباب, I guess it was 0.
0.0
0.05.
0.0556 عشان 3 significant figure.
5 okay 556 ماشي 0.0556 and again degrees Celsius
مستر
per
هو ممكن تطلع سنة؟
second. اوكي كده
مستر هو احنا جبنا 86 و 76 من التبل من
اوكي
ورا يعني على اساس ايه؟
الانيشال temperature اللي هو ثيتا 0 والفاينل temperature ثيتا 180 of beaker B.
يعني ايه؟ لا انا مش
بس
يعني
Okay,
فاهم.
beaker, this is beaker B صح؟
اه
initial temperature 86 final temperature 76
76
بس.
او في اللي تحتها بقى جبنا 86 و 76 واللي فوقيها قصدي ال 85
85
ماينس نفس الحاجة بس في ايه صح؟
56 يس بيكر A. اوكي
يا مستر معلش، هو يعني ايه ما انا عمري ما فهمت يعني ايه
تمام.
ثيتا والحاجات دي.
theta is the temperature. Theta is the temperature. Whenever I say theta zero, what do I mean by theta zero? Theta zero is what is theta? Zero is the temperature at time zero, when the time was equal to zero. When the time was equal to zero, time was equal to zero, find the temperature of beaker A. When theta A, theta zero, but for beaker B it was 86. It's the same. Okay.
هي اسمها ثيتا ولا ثيتا؟
Theta TH.
ثيتا.
Hmm.
تمام.
Okay. Okay. Yep. Thermal energy is transferred from the surface of the water and from the sides of the beaker during this investigation. Assume suggests that more thermal energy is transferred from the surface of the water than from the sides of the beaker. State whether your results support this suggestion or not. More the student, okay, he is suggesting that more thermal energy is transferred from the surface of the water than from the sides of the beaker. Is this correct or not?
Yes.
Yes, it is correct. Okay. Yes, it is correct. Why is it correct?
عشان the beaker left with an exposed surface had a higher rate of cooling than the beaker left with a lid.
Okay. So theta A, which was without a lid, okay, XA, which is when it was without a lid, XA had a higher value than XB, meaning, okay, that more energy was transferred from the surface. Okay. Theta A didn't have a lid, and therefore more energy was transferred from the surface. Okay. Suggest a change to the apparatus or the procedure to produce a greater difference between theta A and theta B. I now need to increase the difference between theta A and theta B.
more time مثلا.
More time? Not necessarily.
larger initial temperature.
Higher initial temperature, definitely. Definitely a higher initial temperature, okay, which is 100% correct. Increase the initial temperature. Okay. Some students investigate the electrical circuit containing different combinations of resistors. On figure 2.1, complete circuit A to show a voltmeter connected to measure the potential difference across resistor X. Okay, potential difference across resistor X and an ammeter connected to measure the current in the circuit. صح? Can I complete the circuit? Yes, I need an ammeter. Okay, ammeter. I need a voltmeter to measure the potential difference across resistor X only. Across resistor X. Okay. And then what about this part? خلاص, I'll fill it in. That's it. A student measures the potential difference V across resistor X and the current I in the circuit. The voltmeter and the ammeters are shown. Record the readings in the table below. يلا, what's the reading of the voltage?
3.3.
3.3. The current? What's the current?
0.82.
0.82. يلا. 3.3 and 0.82. Can I fill out the column headings? What's the unit of V
Voltage
and
V
I?
A.
A. Okay.
بس ممكن ترجع للدروينج معلش.
Hmm.
ايوه ثانية واحدة بس.
يلا, it's a very simple drawing.
خلاص تمام.
Okay. طيب. خلاص, we wrote down the voltage and the current, and now the student now connects two 5 ohm resistors in series between P and Q. Okay, and then she measures the potential difference and the voltage X and I, and then she repeats the experiment. 3 5 ohm resistors. All her readings are shown in table 2.1. Initially, this is the initial circuit, and then this is the second circuit, okay, which is B, and the third one was C. Complete the headings. Okay, we completed the headings. Calculate and record the resistance. Can I calculate and record the resistance? Yes. R equals V over I for each of them. What's the first resistance, the second one, and the third one?
أول واحدة 4.0.
4.0. Okay.
ده كده 3.9 و 4.1.
طيب. Can you write them down in 3 significant figures?
هما كده in 2 هو المفروض 3 ولا 2؟
It doesn't
2.
matter really. It doesn't actually matter. But 3 significant figures would be a little bit better in this question. Okay. So resistance 4.0 what?
2.
4.01.
What?
لا 2.
1 or a 2?
2 يا مستر.
4.02. The second one?
3.89.
3.9.
3.89. The third one?
4.10.
4.10. ماشي.
مستر هو احنا جبناها ازاي؟
آه،
عملنا R equals
أيوه.
V over I.
Yes.
Okay.
Okay. ماشي. حلو. Good. The student suggests that the values of R should be the same. State whether your results support this suggestion or not. R. Are they the same or not? Are they
No,
the
they're
same?
not.
They're not? Why?
هو لازم تبقى النمبرز اللي ما بينهم ليها limit صح؟
Yes. Okay. But it's يعني a little obvious that they are quite close. Okay. These numbers are definitely quite close. And you can calculate it. You can calculate it. For example, I'll take 4.02 as the base reference. For example, I will calculate 4.02 divided by 3.89. Okay. I'll find it to be less than 5%, which is acceptable. 4.10 divided by 4.02, also less than 5%, maybe only 2 or 3%, which is also acceptable. But definitely the three numbers are close and within the limits of experimental accuracy. A statement, are they the same? Yes, they are the same. They are the same. The justification, the numbers 4.02, 3.89, and 4.10 are close and within, yep, and within the limits of experimental accuracy. Limits of experimental accuracy. Okay, حلو. The results can be checked using a different circuit. Draw on figure 2.6 one other arrangement of three 5 ohm resistors between terminals P and Q. What should I do?
هنرسم 2 سيريز مثلا واحدة parallel.
You mean 2 parallel, 1 series? Okay. Okay. Oh, I can draw them all in parallel, for example. It's okay. And whatever. You can draw them, the 3 of them in parallel. Or you can draw 2 of them in parallel and only 1 is in series. Okay. It doesn't matter. Okay. Yeah. The student wants to determine R, draw the circuit symbol for the variable resistor. يلا what's the
مستر
variable?
انا ما فهمتش اللي هي اي دي.
بس هو بيقول لك
آه،
just one
ايوه
other arrangement. What do I mean one other arrangement? Well, initially they were in series. اهو initially the 3 resistors were in series صح؟
مم.
طب what is one other arrangement other than series؟ يعني parallel صح؟ We know a series or parallel. Do you
آه،
know any other arrangements؟
لا
لا فهو it's only series or parallel. خلاص this was series. يبقى I can connect them in parallel. يبقى I connected them in parallel. That's it.
اوكي ماشي.
Okay. يلا. الفاريبل resistor طبعا احنا we know how to draw a variable resistor. A rectangle with an arrow through it. Arrow could be facing upwards, downwards, to the left, to the right. It doesn't really matter. Suggest one advantage of using a variable resistor to vary the current compared to the procedure carried out in B and C. What is one advantage of using a variable resistor?
هتبقى easier to change the resistance بدل ما نقعد add a resistor و remove a resistor.
It's easier, yes. It is easier.
أو to control each أي حاجة لوحدها.
Control the current easily. Okay, you can change the current easily. Yes. Okay, it's all about ease of use. So it is easier to get more easier to obtain more values for the resistance. Okay, حلو. Yes. Next question. We have converging lens. We have distance u, shows the illuminated object. Measure and record the height h note. We will measure this distance using the ruler. Okay, it's very simple. Measuring the distance using the ruler. It should be 2.0 centimeters. It should be 2 centimeters. But if you measure it now using your ruler and using the books you have, probably it will be less than 2.0. It will be probably 1.8 or 1.9, which is okay. Which is okay because this is a printing error. It's not an error in your calculations. It is a printing error. Okay. But initially it was 2.0. The distance u between the illuminated object and the lens is set to be 20 centimeters. Initially, it was 20 centimeters. This is the actual distance. The screen is moved until a sharp image is seen. Measure and record. Okay, measure and record the height hi. This is the image. Can I measure this image again using Again, using what? Using the ruler. Okay, I will measure it using the ruler. Again, your measurement might be slightly less. Okay, it might be slightly less. It should be 3.7. I will write down 3.7 HI. Okay, it could be slightly less than 3.7.
بعد كده اعمل المفروض 1.8 over 3.7 عشان اجيب
Okay, صح.
ال W.
HO was not 1.8, it was 2.0.
انا عندي thread
Okay, I know it's 1.8 and you calculated it 1.8, but let's all use the same numbers for now. Okay, so it was 2.0 divided by 3.7, which should be
0.54.
0.54. Okay. Student repeats the process for 30, 40, and 50, 60, and then we need to plot a graph. Yeah, let's plot a graph. First mark is plot a graph U on the y-axis. Yeah, this is the first mark. U slash centimeters. W on the x-axis. Okay, W on the x-axis. Yeah. كده I took one mark. Should I start from 0 and 0? Should I start from the origin? He did not state. He did not say you have to start from the origin. خلاص يبقى I don't have to start from the origin. Most probably it would be better if I do not start from the origin. Okay. U, let's check U 20, 30, 40, 50, 60. Okay, this could be easy. If I start from 10, for example, 20, 30, 40, 50, and 60. ماشي. W 0.54 up to 3.3. Okay, probably. Okay, can someone suggest a scale for this axis?
I guess 1 for each
0.5.
x squared.
And you said 1?
Yes.
0.5.
لا, 1 is too small. 0.5 would be better. I could start off with 0.5. Okay, and then keep on
But sir,
adding
it covered almost 75% of the graph. I think it's okay. Yeah.
1.5,
لسه هقول
2.0, 2.5, okay, 3.0, 3.5. If you do it 1, يعني you will start from 0, صح? 0, 1,
Yes.
2, 3. لا, that is wrong. اهو بص كده, I will draw it. Okay, I'll use another pen, for example, just to show you that it is wrong. Okay, هنا I will start from 0, 1, 2, 3. Okay, all of your points will be starting 0.50 something, 54, all the way to 3.3, which is up to here. Okay, this is not the best choice. Okay, this is not the best choice. But if you don't have any other options other than this, then you can do it. Okay, if you don't have any other options. But the thing is, you do have options. You do have other options. So it's better to spread out the numbers as much as possible to make sure that you will take the 4 points, the 4 marks. Okay, it's better to spread them out. Okay, we don't want to lose any stupid marks. If you can, then do it. If you can't, خلاص, then that's what's meant to be. Okay, yeah.
Thank you,
Let's
Mr.
let's plot the points. It was what? 20, 0.54, 30, 1.3, 0.54. 54 should be فين? Where should 54 be? Where should 54 be? يلا.
قبل
هتبقى عند
الهاف
ال
بوينت
20 لا، هتبقى عند ال 20 وبعد ال 0.5 بواحدة.
هنا 0.54. This is 54.
هي قبل الهاف.
قبل الهاف. طيب. This is 0.55. Am I correct?
0.75.
0.75. Thank you. This is 0.75. 0.75. Yeah, where's 0.54? Oh, this is 0.50. Well, each small square is worth is worth 0.05. But definitely, as you said, someone said it before, it is after the 0.5 by one square. Only one square after the 0.5. 20 and 0.54. Type the next one. 30 and 1.3. 30, 1.3. Oh, this is 1.25, but 1.3 is after. This is 1.3. 40 and 2.0. Well, this is easy. 40 and 2.0. 50 and 2.9. 50 and 2.9. يلا فين 2.9? It's before 3. Okay, 2 squares before the 3. 60 and 3.3. 60 and 3.3 would be, صح. The gradient of the line, can I find the gradient of the line? Yes, I need to draw the line first and then find the gradient of this line. Okay, yeah, let's draw the gradient. Oh, let's draw the line and find the gradient. Oh. ماشي. Okay, this is the line. We have 1 point above the line, 1 point below the line, which is okay. So how can I find the gradient? I need to measure rise over run. And I need to draw on the graph the triangle method. You have to draw on the line the triangle method. Okay, how can I draw the triangle method? I'll take 2 points which are very far apart. Okay, let's take the first point and the last point. First point and the last point. Okay, you draw these lines using using the ruler. Okay, yeah. Rise over run. To find the gradient, I calculate rise over run. Show clearly on the graph how you obtain the value. Rise over run. Rise هنا it would be from 60 to 20, 40 over the run, which was from 0.54 all the way to 3.3. Okay.
مستر
Hmm.
هتنفع y2 minus y1 over x2 minus x1 صح؟
Yes, صح. Okay. هنا it's 40 over 3.3 minus 0.54, which is 2. Okay, 3.3 minus 0.54. Can someone calculate it for me?
14.3.
14.3. Okay, this is okay. He's saying that this is F, which is the focal length. Focal length. So you can write down the unit if you want. The focal length, the unit of the focal length is in centimeters. If you want, you can write it down. If you don't want to write it down, it's okay. ماشي. A student decides to extend the experiment using larger values of U. Using table 3.1, explain why this could produce less reliable values for W. Again, student decides to extend the experiment using larger values of U. What was U? What was U? Oh, this is U. Again, what is U, يا شباب? It was the distance between the illuminated object and the lens. So he wants to extend the experiment. He wants to extend the experiment. He wants to repeat the experiment for more values of U. 20, 30, 40, 50, 60. He wants to increase the values 70, 80, 90, 20, 100. Suggest why. This could produce less reliable values for W. Why would this produce less reliable values for the image? Any ideas? Hmm. Any ideas? Yeah, it's more of an out of the box question. It's a new question. It's a critical thinking question. But if I use larger values, okay, just think about it. If you use larger values for the distance between the illuminated object and the lens, what will happen eventually? Okay, what will happen eventually? It will become
Might
much,
might get virtual.
might get virtual. لا, لا, it won't be virtual. Hmm. Nice thinking, and I like your thinking, but it will not become virtual. Okay. What happens, what happens to the image? What happens to the image? Okay. What happens to the image? بص يا شباب. When the U was 20, the image was 3.7. U30, image 1.5. 40, 1.0. 50, 0.7. 60, 0.6. What's happening as I increase the U? What's happening as I increase the distance of the object? As the object moves further away, what happens to the image? الimage gets smaller. The image gets smaller. So the explanation, why is it more difficult? The image gets smaller, okay? And it becomes more difficult for me to measure the distance or measure the height of this image. What is one improvement? How can I make it even better? If the image is getting smaller, can I use a larger object? Yes, I can use a larger object. Okay, I can use a larger object. So instead of finding a very small image, I can use a larger object. So whenever the image of this object becomes smaller or gets diminished, I can still measure it to a very high accuracy. So improvement, get a larger object. Okay, ماشي. Last question. A student investigates the factors that affect the average speed of a ball falling in water. The factors that affect the average speed of a ball falling in water. Plan an experiment, in which will enable him to investigate the effect of one factor, effect of only one factor. We need to find one of the factors, okay, on the speed on which a ball of modeling clay falls in water. يبقى again, we need to see one factor that could affect the speed. What could be one factor that could affect the speed of the ball?
The surface area. The
Surface.
section, I mean, like the
Hmm.
the area that it moves on.
Its surface area is not wrong, but so whenever you increase the surface area, so the size of the ball will increase. So you mean the mass of the ball will increase. صح? Again, if you want to increase the surface area, what happens to the mass of the ball? It definitely will increase. يبقى you are correct. One of the factors. What is the factor that I will be changing? What is the range of values? Okay, range of values. Okay, what is the factor I will be changing? What is the factor I will be changing? The mass of the ball. What are some suitable masses that I can use for this equation, for this experiment? What are some suitable masses? يلا, give me some suitable masses. Any ideas? Can I use 10 kilograms, 20 kilograms, 30 kilograms?
Maybe.
لا, not maybe. That's definitely wrong. That is definitely wrong. You cannot use these huge masses. Okay. In any experiment we need to use very small masses, or rather small masses. 50 grams, 100 grams, 150 grams, 200 grams, 250 grams. That's the maximum. Okay. طيب state clearly what is the factor. خلاص احنا we did what is the factor. List of any additional apparatuses that will be used. Okay. Additional apparatuses, I'll write them down. State any key variables. So let's write down the key variables. What are the key variables? What are the variables that will be constant? What are the controlled variables in this equation?
The same density of the water, maybe.
طيب. Will the density of the water affect the speed at which the ball falls? Well, you need to think about it this way. Does the density of the water affect the speed at which the ball falls? لا, it doesn't. What factors could affect the speed of the ball while it's falling?
الديستنس.
Distance. حلو. صح. Distance above. Distance above the water. Distance above the water, which is the main factor. Okay. This is the main, definitely the main factor. Okay. طيب. What are some apparatuses that I will need?
Maybe a balance scale to measure the ball.
Okay, let's check out if he gave me any apparatuses, modeling clay, metal ball, transparent. Okay, we can use balance. What else?
Meter ruler.
Meter ruler, yes. What else? There's one very, very important apparatus you must write down in this question. You have to write down this apparatus in the question. What is it?
ستوب واتش.
Stopwatch. صح. You have to write down the stopwatch. حلو. These are the apparatuses and the controlled variables. Okay. These are the apparatuses, controlled variables. State how will you carry out this experiment, and then write down a conclusion. Okay. You may draw a diagram if you want. How will I carry out this experiment?
مستر، هو احنا ممكن نعمل تيبل للجرامز وتيبل للديستنس اللي هتقع منه البول وكده.
You don't need a table. Did he state you must draw a table?
لا، يعني هو لو مش قايل اللي هو عايز تيبل ما رسمش.
بس كده. Yes. If he didn't state it clearly, then don't draw a table. Okay. يلا. For each يلا. What is the method that I will do? What is the steps? What are the steps that I will be conducting? For each ball, measure the mass. Measure its mass. And then drop the ball. Drop the ball from a constant or a distance. Okay, from a distance above the water. Measure the time. Measure the time it took to reach the water. Okay, measure the time it took to reach the water using the stopwatch. Then I will calculate the speed. How will I calculate the speed? Equals distance over time. صح? And then you have to say, repeat this experiment for each, you have to say it, repeat this experiment for each mass of the ball. Okay?
ومش نقول المفروض وتيك افريج برضه.
اوكي، ممكن تقول take average. Repeat this experiment. يلا. For each ball and take average. You have to do it. You have to repeat and take average. Okay. Um, okay. What about the conclusion? Okay, خلاص, we said repeat and take average. Okay, we can, and as for the conclusion, we can say draw a graph, for example. Okay, or draw a table. Draw a graph is actually better. Why should I draw a graph? To compare the results. Okay, draw a graph for the mass and speed of each ball and compare the results. Yes, that's it. Okay, that's it. حلوة.